Assalamualaikum and hi everyone. Today we will continue on the properties of the inverse Laplace transform. In previous example, we have learned about finding the Laplace transform, when we are given ft. So example, to find the Laplace transform of ft, so it is given by fs. Now in this topic we want to find the ft when we are given fs. So to get ft, we use the inverse Laplace transform. So inverse Laplace transform of f, capital Fs, is actually equal to ft. Alright, so for example here, we have inverse Laplace of 5 over s. So first we have to look at the pattern of s here. It is located on the denominator. So based on this table, it is similar to this form, a over s. I just copy this one, right? A over s. Where a is equal to 5. So means that inverse Laplace of a over s is equal to a. Right? So it means that inverse Laplace of 5 over s is actually equal to 5. Next example, we have Laplace of 1 over s power 5. It looks similar to the n factorial over s n plus 1. Maybe I can copy this one back. N factorial over s n plus 1. We look at the s here. The pattern is similar. So value of n here should be n equal to 4. So when it is equal to 4, so down here it should be s plus power 5 back. And then upside here we have 4 factorial. 4 factorial. Right? But 4 factorial. But the equation here, the original equation, it states it must be in terms of 1 value. The value must be 1. But based on the formula, we should get in terms of 4 factorial, so that we can convert back into t power n. So how to make it? We need to modify this equation in order to get the similar form with the original equation. So what can we do? So since this one is 1, so we can multiply back with the 1 over 4 factorial. Right? So why we multiply by 1 over 4 factorial? Because this pattern must be similar with the table. And we need to multiply by 1 over 4 factorial in order to make it similar with the table and similar to the original equation. So this one is equal. This is equal to the previous example. So when we use the table, we can get 1 over 4 factorial, 4 multiplied by 3 multiplied by 2 multiplied by 1. Inverse Laplace of 4 factorial over s power 5 is actually equal to t power n. So t power 4. T power 4. So we will get the answer will be t power 4 over 24. We move to the next example here. Inverse Laplace of 5s over s squared minus 4. So first, when we observe from the table, it is quite similar with, we have s upside here, s. Denominator, we have s squared minus 4. We look at the negative, we have s squared, we have s. So it is similar to the cosh. Cosh, because we have s squared minus a squared. So we need to try to rearrange until we get the similar form with the table. Okay, so 5 here we can bring out. Okay, let's say I bring out first. This constant we can bring out s over s square minus 4. Then rearrange into a power 2. So we will have 5 inverse Laplace s over s square minus 2 square. So we get the value of a is equal to 2. Okay, so the answer will be 5. Okay, this is the similar to the table. So we can conclude into cos 80. 80 is equal to 2t. Okay, we move into another example. Inverse Laplace of 1 over 2s minus 3. So what do you think? Is it equal to? It's supposed to be equal to 1 over s minus a. Okay, because s is only in the denominator. So we need to try to rearrange until we get the form of 1 over s minus a. We want it is in the form of 1 over s minus a means what? Value of s must be 1 here. We only want 1. But in this case, we have 2. Okay, so what can we do? We can bring this one out. Okay, we try rearrange first. So we factorize 2. We get s minus 3 over 2. Okay, so when we multiply by, we get 2s minus 3. Alright. Then after we factorize, we can bring this one out. Then we will get 1 over 2 inverse Laplace 1 over s minus 3 over 2. Okay, then the solution will become 1 over 2 exponent 3 over 2t. Okay, because a here is equal to 3 over 2. Okay, next 3s inverse Laplace for 3s plus 8 over s squared plus 4. So how to integrate this one? So we can split. Okay, so since this one we don't have this type of pattern, okay, from the table, so there must be another way we can split this one. So it is equal to inverse Laplace of 3s over s squared plus 4, okay, plus inverse Laplace of 8 over s squared plus 4. Okay, remember, if you want to split a plus b over c, always bring the same denominator. Okay, b over c, right? Mesti sama value c. Okay, let's move and let's continue. Okay, so when we split this one, okay, look at the pattern here. S over s squared plus 4. This one is quite similar with the cos. Okay, cos. So we need to get a power 2 and 3 here we can bring out. So we have inverse Laplace of s over s squared plus 2 square. Right? And then here we have 8 over s squared plus 4. 8. Okay, the upper here is constant, and then denominator we have s squared plus. So s squared plus, it must be sign. So a must be same. We should have 2a. Okay, for numerator and denominator here. Okay, so a here should be 2. Okay, a should be here 2. We refer to the a power 2. Okay, because we cannot change the value itself. We cannot control the value of a. Okay, so a should be power 2. So what can we do is I bring this one out first. Okay, inverse Laplace. Okay, so we want up here to be a. A should be 2 over s squared plus 2 power 2, right? From the table, I want it to be similar with the table because a over s squared plus a squared. Okay, so since I put 2 here, so I need to put back over 2 here. so that when we simplify, we get back the same coefficient as the previous equation, right? Okay, so why do I have to put 2 and 2 here? Because I want to make the inverse Laplace similar with the table. Okay, must be similar with the table both. Alright, so when we want to find inverse, okay, so this one s over s square plus 2 square equal to cos 2t. Okay, plus 8 over 2 equal to 4. Inverse Laplace of 2 over s square plus a square is equal to sine 2t. Okay. Okay, let's move into another topic of first shift property. So for the inverse of first shift property, we will find the inverse Laplace transform of f where the function has s minus constant. Okay, any s attached with minus constant. Okay, we can convert it into EATFT. Okay, by using the inverse Laplace transform. So let's look at the first example here. Inverse Laplace of 1 over s minus 4. This one we can solve by using first shift property because it has s attached with the minus constant. Okay, s attached to minus constant. So in this case, we have a equal to 4. So we can, we try to define first. So fs minus 4 is actually equal to 1 over s minus 4, right? Okay, because it is similar to the s minus 4. So we have a equal to 4. So we can substitute into a here in the formula. Then in the formula also we have ft. So how to get the ft? So to get the ft, remember it is actually equal to inverse Laplace of fs. Okay, so we need to find what is fs. How to define the fs? Based on the fs minus 4 here. Okay, so here we have fs minus 4 equal to 1 over s minus 4. What if we change into fs? So means every single s minus 4 must be substituted with the s. So 1 over s minus 4 will become 1 over s. Right? So we just substitute into this formula. So inverse Laplace of fs is equal to 1 over s. Okay, then we will get the answer is equal to 1. Right. So inverse Laplace transform of 1 over s minus 4 is actually equal to EAT, A equal to 1, T, FT, FT equal to, E equal to A equal to 4, 4T, FT equal to 1. Okay, so simplify, we get E4T. Okay, for the second example, maybe we can bring out first 5 inverse Laplace of 1 over s plus 2 power 3. Okay, then we try to extract the information first. Okay, so we have, this is considered as first shift property because every single s is attached to the minus constant. So in this case, we have a equal to minus 2. Okay, because we need to have minus some constant. Okay, so when we have a equal to minus 2, then we can consider this form as our s minus a, right? So let's say I just know 5 rule. Later we substitute back. So we have s plus 2 is equal to 1 over s plus 2 power 3, right? Okay, because we assign as s plus 2, where a equal to negative 2. Next, we try to get the information. We want to find the value of a and ft. So this is fs plus 2. Next, when we get s plus 2, find fs. Okay, so means every single s plus 2 we need to substitute with fs. s. So we will get the answer will be equal to 1 over s power 3. Okay, so for fs. So from fs here we can find value of ft. So inverse Laplace of ft is equal to inverse Laplace of fs. Okay. So sama dengan inverse Laplace of 1 over s power 3. Okay, so rearrange to get the equation inverse Laplace of suppose s power 3. Okay, atas should be 2 factorial, right? So we put back 1 over 2 factorial. Then we will get the answer is 1 over 2 s power 3. Okay, so we have n equal to 2. So t power 2. T power 2. Okay, so this is value for ft. Right, so in this solution, we go back to the question. We want to find the inverse Laplace of 5, inverse Laplace of 1 over s plus 2 power 3. So this one, it is actually equal to 5 EATFT. So we just substitute the value E. A equal to negative 2t. Ft equal to 1 over 2 t power 2. So make it simplest form. So we get it is equal to 5 over 2 t square e minus 2 t. Okay, last example. Inverse Laplace of s plus 1 over s plus 3 power 2 plus 16. Okay, this one we can solve by using first shift property because it has every single s attached to constant. But there are different constant here. We have plus 1 and plus 3. So which one to choose? We only need to choose one constant. So in this case, I prefer to choose plus 3. Okay, so A equal to negative 3. Because why? It is hard to change the constant here because it is in the bracket of the power 2. Okay, so maybe we can just stick with the A equal to negative 3. So we want to make sure that every single s is attached to plus 3. So define first our f s plus 3 is equal to s plus 3 power 2 plus 16. So how to modify the s plus 1 here into plus 3? Okay, the easiest way is just to put s. We want it to be plus 3. Put plus 3. Then put minus 3. Then we just copy back the original equation. Okay, so when we put plus 3 minus 3, then it will come 0 back and s plus 1 is similar to the original. But we need to put here because we want to get in terms of s plus 3 for every single s. Okay, so when we have put this one, I just put bracket so that we know we end up with the s plus 3 here. So when we get fs plus 3 form, then we convert into fs. Okay, when we have fs, so means every single s plus 3 we change into s. So this is s plus 3, we change into s. Alright. So the left one here is minus 3 plus 1. It will become 1 minus 3 equal to minus 2. Over s plus 3 here become s. So s squared plus 16. Alright. So this is our fs. So next, when we get fs, we find ft sama dengan inverse Laplace of fs. So our fs is s minus 2 over s squared plus 16. Alright. So equal to, so we can split this one. We will get the answer is s over s squared plus 16. Okay, I just split this one. S over s squared plus 4 power 2. Okay, minus inverse Laplace of 2 over s square plus 4 power 2. Right? Split this one. Then we will get the answer is s over s square plus 4 square is equal to cos 4t minus 2 over, okay, so upside here it should be 4. So I just bring out 2 here over, okay, this one should be 4, yeah. So we put 4 back. So we will get s square plus a square is equal to sine 4t. Okay, so this is value for ft. Okay, so we just substitute back. So f s plus 3 is actually equal to, okay, inverse Laplace of fs plus 3 EAT. Our A is equal to, just now we substitute A equal to negative 3. Negative 3t times ft. Ft is equal to cos 4t minus 1 over 2 sine 4t. Right? Kenapa aku bagi soalan susah ni? Itulah.